Today we are going to do this problem, and this is a electrical circuit with the voltage source of 100 volt. EMF is 100 volt and an internal resistance is 2 ohm. There are 5 ohm resistance, 1 ohm resistance in series, and there is a combination of two parallel resistance 6 ohm and 3 ohm in series with the 5 ohm and 1 ohm resistance. Now you are required to find out the power consumed by each resistance. So the step to solve these problems, the method is like this. Step one, find out the total current flowing through the circuit. For that, you need to find out the equivalent resistance of the circuit and then divide it by the EMF. Then you need to find out the current through each resistance. The current through this internal resistance and this 5 ohm and 1 ohm will be same as the total current, but the current through this 6 ohm and 3 ohm, they will not be the same as the total current. The current gets divided into these two resistances in the reciprocal ratios of their resistances. You need to apply current division rule here. You need to apply current division rule here and find out the current through each resistance. And then the third step is to find out the potential drop across each resistance. That will be you know the resistance, and if you know the current through each resistance, you can easily find out the potential drop across each resistance. And once you know the potential drop across each resistance and the current flowing through each resistance, then you can easily find out the power consumed by each resistance. This is how this problem should be done. So step one, first find out the total current. So first you need to find out the R equivalent. R equivalent is this two internal resistance plus 5 plus 1 plus parallel of 6 plus and 3. So that comes to 10 ohm. So the total current is 100, EMF divided by the total equivalent resistance 10, that is 10 ampere. Now the second step is to find out the current through each resistance. Since 5, 1, 2, they are in series, so the current through them will be 10 ampere only, but the current through 6 and 3 ampere will be different. Now we know the current division rule. In the current division rule, current flowing through 6 ohm resistance, current flowing through 6 ohm resistance will be equal to 3, the resistance in the other path, divided by the sum of the two resistance 3 plus 6 into the total current. That's what I have done. 3 into 10, the total current, divided by the sum of the resistance of the two paths. So that comes down to 10 by 3 ampere. Second, current through 3 ohm will be then the resistance of the first path 6 ohm divided by the sum of the two resistances 6 plus 9 into the total current, which is 10 ampere, and therefore the current through 3 ohm resistance will be 20 by 3 ampere. 20 by 3 ampere. So this is how we will find out the current through each resistance. Now for step 3, you need to find out the potential drop across each resistance. So potential drop across 5 ohm resistance is R into I. R is 5 ohm and I current through the 5 ohm resistance was 10 ampere. So it is 5 into 10, 50 volt. Potential drop across 1 ohm is 1 into 10, 10 volts. Potential drop across 2 ohm will be 2 into 10, the current through it, 20 volt. And now the potential drop across 6 and 3 ohms, they will be same because they are in parallel. So you can calculate any one, the second will be same. So I have calculated both. Potential drop across 3 ohm is 3, the current resistance of that resistor, and the current through 3 ohm resistance is 20 by 3. So 3 into 20 by 3, that gives you 20 volts. Similarly, potential drop across 6 ohm will be 6, the resistance, value of resistance, into the current through the 6 ohm resistance, which was 10 by 3. So that comes again as 20 volts. Next, the final step, step 4, power consumed by 5 ohm resistance is the multiplication of the voltage drop across the 5 ohm voltage drop or the potential drop across the 5 ohm resistance and the current through the 5 ohm resistance, which is equal to 50 into 10, 500 watts. Similarly, power consumed by 1 ohm is the voltage drop across 1 ohm, 10 volt, and the current flowing through the 1 ohm resistance, 10 ampere, 100 watt. Power consumed by 2 ohm resistor is 20, the potential drop, into the current through it, that is 10, 200. Power consumed by 3 ohm resistance is the voltage drop across it, 20 volt, into the current flowing through it, 20 by 3 ampere, 400 by 3 watt. And power consumed by 6 ohm resistance is 20, the potential difference of potential drop across it, into the current flowing through it, which is 10 by 3 ampere. You get 200 by 3 watt. This is how you should do the power consumption problems.